So on the blank page on page 192, we are going to do the following example. We are going to graph y equals 3 times 1/2 x cubed. So most of the examples that we've had so far out of the textbook, they've given you a graph and asked you to do transformations. This example is using those sheets that we did at the beginning of the year and saying, can you recognize what parent graph is there based on the equation? And then if you know what that parent graph is and what it looks like, can you then draw this graph? So of those 4 sheets that we did this at the beginning of the year, what do you think the parent graph is for this one? Do you think it's the square root of x, the 1 over x, the x cubed, or the absolute value of x? X cubed. So one of the things that you're going to do is you're going to have to be able to say, I recognize that I have a cubed and I have an x. And so that would be my parent function. So the first thing you would do in a question like this is off to the side, we could draw a quick sketch of x cubed. Since we already have memorized the shape, and know some points on the graph, again, if you've forgotten the points, you can always find them by making a table of values. What happens when I put 1 in for x? 1 cubed is 1. What happens if I put 2 in for x? 2 cubed is 8. So those points you can find if you've forgotten them, you can find them with the table of values. So now we have to decide, well, what's happening to our graph? I highlighted the x and the cube to realize that's part of our parent graph, but we've got a 3 and we've got a 1/2 there. What do those things do? What does the 3 do? That affects the y. Good. Because can you see that that 3 is outside of the function? That 3 is not getting cubed. So that's going to affect the y values. It's going to be, if we write it out in words, a vertical stretch by a factor of 3. What we're going to show as our work, in shorthand, we can just say our y value is going to get multiplied by 3. So that's what the 3 does. What does the 1/2 do? Close. Horizontal. So that 1/2, you see how that 1/2 is inside the function. It's getting cubed. So it's going to be horizontal. And it will be a stretch by a factor of 2. So now we're going to multiply our x values by 2. So as far as showing our work, we can take the points that we had on our original graph. We've got -1, -1, 0, 0, 1, 1, and 2, 8. And we can say above these arrows what we have in the green there. We need to multiply our y values by 3 and our x values by 2. What's going to happen to those points? Well, sometimes I find you make less mistakes if you concentrate on one coordinate at a time and do all of that coordinate. So if I want to do my x values by 2, I'm going to get -2, 0, 2, and 4. And then I'll concentrate on my y coordinates next. All my y coordinates get multiplied by 3. So now I'm going to get -3, 0, 3, and 24. So it might be that one of these points we won't even graph just because it's way off of the charts already. But we can set up a new grid for our graph. We know that we'll have the point 0, 0, 2, negative 3, and 2, comma 3. It's going to have the same shape that we had before and go through those points. Now, I purposely did something here which would cause us to lose a half a mark on the final exam. What haven't I done? Sorry? Didn't write the new equation. They actually would be fine with that, but that's not a bad thing. That's not a bad thing to do, to actually label it. This is 3 1/2 x cubed. It's not bad to label that, but that wouldn't be the thing that they're looking for. I need to label some points, because even though it may seem obvious that I've gone over 2 and up 3, we haven't given any indication what those marks mean. I could have gone by 2s, right? This could mean go over 4, up 6. So we need to indicate what our scale is on this graph. And so the best way to do that, if I label that point 2, comma 3, that defines each of these marks as going by 1, and these by going by 1. And then labeling this point negative 2, negative 3. That is already obvious from the other point label, but it's important to label your points. I did remember my arrowheads on my end of my graph. In some courses, they're even particular that you say that this is your x-axis and this is your y-axis, but they won't be particular about that on the exam. Usually they give you a grid on which to work with. So to recap, we looked at our original graph. We had to recognize what our original graph was. Then we figured out what kind of transformations happened. We took our points from our original graph and applied those transformations. In this case, we had to multiply the y coordinates by 3, the x coordinates by 2. And then once we have our new points, we could graph it. Notice I didn't graph 424 because it would be way high up. That's okay. But you need to have at least 2 points graphed and labeled on your new graph. Does the graph have the same shape that we have? Does it appear that your y values have been stretched and your x values have been stretched? It's good to just sort of get a sense. Does it seem like it's right in the end? And in this case, it is.